Welcome to IIoT Live Lab here on Industry4.tv. This is a weekly live show where we explore tools and techniques for building the connected factory. My name is Kudzai Mandi Teresa, and this show is sponsored by HiveMQ. And today we're going to be talking about harmonizing OPC UA data sources using Prosys OPC UA Forge. And joining me today to conduct the presentation is Pyry. So I'll let you introduce yourself to the audience.
Okay, thank you, Kudzai, and it's really like a privilege to be here at the Industry 4.0 TV, like you host, and like looking back, like the other guests you have had here, so kind of feel honored to join that club. But yeah, going to the point. So yes, my name is Pyry Grönholm, and I am CEO at the Prosys OPC. My background is in software development, like everyone in our company basically are coming from the engineering background, and I joined the company like already 25 years ago as a summer trainee, and then worked along my studies in computer science, and then started to move a little bit like to the managerial positions. The Forge I'm presenting here is really something I would love to have had like during the years that I was head of our customer projects and integrating like OT and IT. So basically like all of my career, that's what I'm being doing. But hey, let's go to I have a few slides to start with. So if I start to show those first.
Yeah, so while you bring up the slides, for those in the audience, please feel free to drop your questions in the comment section below. We're going to address all your questions as we go along. So already I see we've got people who've joined online. We've got Leonard. Leonard, it's good to have you on the show. Yes, we've got Ravil as well. Ravil, welcome. Thank you so much for joining the show. Okay, so you can go ahead and start presenting.
Thanks, and I really like appreciate also that you don't need to do everything yourself. So if I anyway start a little bit about the company, so for those that doesn't exactly know what we are.
Sorry, Pierre, are you can you share the slides?
Yeah, I thought that I was sharing the screen, but seems like I'm not doing that. But
yeah,
let's see. Go. Yeah, okay, there we are. So about the company. So we are located in Espoo, Finland. That's in the Helsinki metropolitan area. Basically, our office or headquarter office is on university campus. The university is Aalto University, which is biggest technical university in Finland that we basically can see from our windows. Then a few facts. So we have been here for quite a while. Of course, like we have been forced to change our approach a few times, although we have done industrial software all the time. But of course, for example, the OPC didn't exist basically 1995 when the company was founded. We feel that we are like world leader in the multi-platform OPC UA software development, meaning that our deliveries are really global. Also, like our own technology is based on Java, and Java is kind of like multi-platform by nature, and this way, like all the products that we do, that you can run it on any platform that is running Java. But then let's go the demo itself. So I will a little bit tell in advance like what I'm going to present. So I will start about the Forge, then I will introduce the demo setup. I will introduce the features that I am about to demonstrate. And then in the end, I will also tell the features that I didn't demonstrate but exists. But at this point, if there is no questions, I could actually like jump to the demo itself.
Yes, please.
Sorry. No, I'm not going to do that because I was still in the outline. Let's anyway take a look. Actual content, sorry. So the Forge, from the beginning, the idea was that what we'll do is that it's a modern application. It's containerized application with a web interface. And the idea was that it should enable the really smooth integration of the IT and OT. Like, and we with the customers, we felt that there was a few things that were always a problem with the project. That was the data was unharmonized. The integration between to the cloud was always like somehow tricky, and you always needed to set up some kind of local buffers for the data so that you guarantee that it doesn't get lost. Although the idea was the containerized application, eventually the Forge can be also installed standalone. So for example, today in the demo, it will be like a standalone installation in a Windows laptop, just running as a service. And if you think about where you should put the Forge in your factory or plant or wherever you would like to put it, like this would be the place. So between the IT and OT, and all the data sources that can support the OPC UA have actually like can be connected to Forge, and if the data sources doesn't support OPC UA, then you can use gateways to convert them, and probably like some of the data sources that doesn't support in OPC UA can be in future also connected directly to the Forge. The InfluxDB is the persistent data store we use for the buffering, but of course, like you can access the data directly from there. And also, like once you put the Forge in this position, then it allows you to control all access to the data in the factory floor from one single point, which is kind of like the access to the Forge. I have some customer cases where this is actually not the position where they plan to put the Forge and where they plan to use it. Instead, they will have like a one Forge for each machine. And that use case is feasible in a cases where you want to automatically deploy a setup for a machine which will retrofit the old one with a standardized OPC UA Information Model, and then it just acts as the OPC UA server for that single machine.
So maybe quickly before, I've just got a quick question there. So in the you mentioned a situation whereby a use case where some customers are considering deploying a Forge right on the machine. So would that be a case where you have got multiple Forge instances and then one central Forge instance doing the harmonization of all the other instances?
Not exactly. So in those cases, like the idea is that they would have like let's say 5 to 10 different type of machines, which are from very different generations, and they kind of would like to have every machine that is the same type, let's say injection molding machine, to have exactly similar information model. Of course, what they could do is that they had one centralized forge and do it exactly the way I'm going to show it today in the demo. But they kind of feel that for their cases, it would be like more feasible to kind of like have an automated deployment script that deploys like the containerized forge just on top of the PLC of the machine, and then kind of map that to their standardized information model. And then all the MES systems and others kind of communicate directly with the machines, but they just need to do like, because the information model is standard, so the MES should have only one connector per machine type. So I think it's a little matter of taste, like how you do it. And I would say that this would be the most typical, but now I've just learned that some companies would like to have it differently, and that would of course enable probably easier like machine to machine communication and these kind of things.
Okay, perfect.
Yeah. And of course it doesn't like kind of, even in those cases you could have like one centralized forge which then would actually like act as a security server to restrict the accesses or whatever. So the key benefits, of course, it's the data harmonization, then it's the security. Like I told, like now it's possible to kind of restrict and control the access from one single place. The cloud connectivity, and then the event-based communication. So with the Forge, you can kind of convert these kind of read and write type of data sources to support like event-based communication. The demo setup today. So I will have like the simulation server as the data source. Then I will use the Prosys OPC UA browser in quite many times to show kind of like step by step when I do the configuration. So because with that I can connect to all the OPC UA servers I have in this setup, as well as I can connect to the MQTT broker. I of course have the Forge, and then I have a HiveMQ, like a free tier cloud MQTT broker, in which I push the data from the Forge, and then on top of that I have, now I need to say that we have made like a Grafana dashboard which shows the data eventually and reads from the MQTT broker.
Nice.
And here is a little animation of the like data harmonization and the cloud connectivity, which I plan to show you. Okay, but now it's probably time to go to the actual demo, and feel free to ask any questions if you have. So everything starts from the Prosys OPC UA simulation server, which now will act as not one but two wind turbines in this demo. And here I have made like two folders, which each have three variables. Of course, like if I would be like monitoring a real wind turbine, there would be a few more parameters, but for this demo purpose, like I feel that less is more. And as you see, like that on purpose, I have now used like totally different type of naming conventions in these variables. And I also have used kind of like a different engineering unit when it comes to this power variable. So here in the wind turbine 2, it's a watts. So as you see, the value is something like 33,000 right now, while in the wind turbine it's right now 50. Of course, like the simulated values here, like they are just something, so they don't, well, they represent a real world case, like as much as something that doesn't understand anything about the wind turbines can create. But that's anyway the start. And now if I take our browser here, which is a generic free OPC UA client, you can see that I can kind of subscribe to these values, and I can see that they are changing here at the simulation server. Okay, but that's the start and the explanation where the data is coming from. Now, the next thing is that I will go to the Forge user interface. And here at the OPC UA servers tab, you can see that I have connected to the simulation server that I just showed you. And here, of course, like in most of the cases, like using the add connection button, I would connect to multiple OPC UA servers.
So there, do you just looking at your servers there, is there, what other mechanism of discovery is it possible to do an automatic discovery of servers there, or do you have to connect to them, or is it even possible, right? Or do you have to connect to them manually there?
Well, in real world, like, yes, you need to just know the URL or URI. So for example, like if I open up like the simulation server here, you can see this you can copy paste it from here. In OPC UA, there is like discovery services as well. There are two types of discovery services. One is local, which means that it will kind of give you the auto like it will be like on a standardized port on certain machine, and it will tell you all the OPC UA servers in that specific machine, and of course like this kind of discovery there is global discovery server, which then it's not a really global, but like would mean that you can find all the servers in a specific factory or network or some like anyway restricted entity, and that would enable kind of like auto discovery of the whole factory. Unfortunately, these are things that are a little bit still to come in real world cases. Like the application exists already, but unfortunately like they are not yet there when you go to the clients, but hopefully in a few years. Yes.
Okay, perfect.
Okay, then if I go to this modeling part, so and going back to this especially this GDS, like I really like see that if you're creating like a factory from scratch, then definitely something you should think about that you install right away from the beginning. Yeah, but like if I go now the Forge and back a little bit to the demo, so and the modeling, so here you can see that I have imported an own information model for the wind turbine, like and in this view, like you can import either like the companion specification that you can find from OPC Foundation GitHub, like for different type of machines, or if you create with tools that are available your own information models, so you can import them here. These information models that you import, like they can contain like both the objects and instances. So if you actually use, let's say, the UA modeler tool, which we have used to do this windmill or wind turbine model, you can actually already kind of model the whole OPC UA address space, including the instances. But like in this case, this model doesn't contain any instances, so it just contains the models, and then you need to create the instances yourself in the user interface. And here in the namespaces, you can see that the added namespace is here at the bottom. So here is one wind turbine that I have already created. So it has these three value nodes, and each value node has also two attributes. Sorry, not all, but this has two and the other one has one. And the attributes are kind of metadata explaining the value. So in this case, for example, there is an engineering unit attribute that will tell that the value of this wind direction is a degree, and the range attribute will tell that like the possible values that it can get is between 0 and 360. What I can do here is that I connect with the browser. To the Forge, and here they are like the values are now coming from the simulation server, and then they are being like harmonized with the standard namings and the structure here within the object. But also now if I, for example, go here with the power engineering unit, like check the attributes, so you can see that the value display name is kW and description is kilowatt. So this is really like standard way in OPC UA to create the information model. So you add like the metadata that exists, so that the client that is connecting and reading the data doesn't need to guess anything. Okay, further, then the data is now there, and I show that I can read it with the client. So now if I go to the PubSub view, so there you can see that I have created one dataset, including the variables of the first wind turbine. I also create a publisher that is now connecting to this HiveMQ MQTT broker, and then within that, like I have one dataset writer, which then kind of push the data from this data set that I made to this topic. And in OPC UA over MQTT, the data is published on one topic, but then there is another topic for the metadata, and you can see the topic here. Now, once again, we can go a little bit to the browser. Now I have also connected our browser to this MQTT broker. And here you can see the data that is in OPC UA format, like on the MQTT broker, they can be displayed this way here on the browser. So we will see like the topic here, and then a little bit like information about where the data is coming from, and also like the display will kind of show the values, and we can even like have a graph about the value. Then on this log part, you can see the actual JSON messages. So these are the actual value messages. Now there seems to be like a little bit extra metadata messages, which I probably would get rid of by clearing the, for example, like these, because those actually there is nothing at the moment like published on those windmill 2 writer. metadata topics. Okay, and of course this is one way to present the data, but then like the little bit more nice way to present the data would be, for example, on a dashboard like this, so which we have made with the Grafana. So this is connecting to the MQTT topics, and then like displaying like the values here, pretty much on the real time. Of course, like now in this setup, demo setup, that the kind of intervals for the polling or the subscription intervals are around 1 second, and when there is multiple steps, so it's not exactly like real time in the automation way, but real time in the IT way. So there is like probably 1 to 2 second delay. Okay, but now that was the setup. I'm starting the actual the demo, like how to actually like add new things on the Forge, and it works in such a way that now here under this object folder, I now planning to add a second wind turbine. So I choose the first like the model, like kind of like the file, or now of course the URI, like which is included in the file where I want to search these models, and then I choose the model, and then I press save.
So just quickly, if you could just show up that screen. So I noticed there's a local instance, an option to select other local instance or remote reference. What does the remote reference in this case mean?
That means like that I can show you. So instead of creating something new, I could also say that, hey, I want to bring something like as such from an underlying server. So what I could do here is that let's say, I don't know if I have any better options, but let's say I want to bring like something directly from the like underlying server. So now I added this this is the node, but it just copied. It's not anymore in the address space of the simulation server, but now it's address space on the Forge.
Okay, that makes sense. So you can either bring in a whole model, or you can access the nodes discretely as discrete items directly.
Exactly. So and now, like when I brought this wind turbine 2 here, these like how, if I show it like here from the browser, so I need to go there and refresh. So this power GW that I brought, that is directly from the sim server, it has like a value already, because like well, it's exactly the same node that is exists
Yep.
there at the simulation server, except that now it's in the topology here under the Forge kind of own topology. But now these like wind turbine 2 nodes, which I just added like an empty instance that is not linked to anything. They don't yet have any values.
Oh, nice.
But that's of course not like not going to last forever, because now what I'm going to do is that I'm going to map them on the values on the underlying server. So here I could either give the node some static value that it's always something. So, but in this case, of course, doesn't make sense. But in some cases, like if it would be, let's say, metadata of the machine, and that doesn't exist on the machine OPC UA server, I could here have like a static value for vendor and make and serial number and such, so that any asset management system that is connecting to the address space could actually still get the data exactly the same way as it gets from those machines that have those like on the OPC UA server.
Yep.
And in a way like use same kind of auto discovery and auto configuration. But now I choose the node and sorry, now this is not where I should go, but to the remote server, sim server, simulation, and then here, and I hope I was mapping the wind direction, and save. So now this node should have a value as well, which is coming from the simulation server. Now I do the same mapping, or not the same, but similar. For the wind speed. And then I left the power as the last one, like in purpose, because there the mapping is not that straightforward, because if you remember in the beginning, like now the value on the data source is in watts, but in the information model, like we require kilowatts. I still do the apply, but now I need to go to this advanced options and do scale or enter a scaling factor here. So it will kind of like convert now the value from watts to kilowatts.
Nice.
And there we go. Now, if I go to this back to this browser, like we can see that these nodes that are let's see like that I just created and I subscribed here, they now have changing values. So the data is coming from the underlying server. Well, now I suppose that we still want to have them in the cloud. So I will create like a new dataset. and I will add the variables to the dataset. By default, like the published name in OPC UA MQTT is such that there is this kind of like a node ID in the beginning, making it like unique for sure. But to like make the Grafana dashboard a little bit like looking better, I will now remove this. Because they are anyway unique. In some normal integration cases, I would say that it doesn't typically mean anything. Now I go to this existing like connection or the publisher that is publishing already the data for the windmill or one. So now here is the one dataset writer. So I plan to create another one for the new datasets. And of course, I need to choose the dataset, and actually I need give that an ID for it. So here in the bottom, you can see the default topics in which like the data would be published, and this is according to the not the OPC UA MQTT spec doesn't really force using this kind of topics, but it kind of like recommends it. Now, once again, in this demo, I do little changes. The Grafana didn't like columns, so I remove those. And then I press add, and here we have like the dataset, and it should be publishing data to cloud. And how we can verify it is that I check my subscriber here, and I see that like now I have here 2 topics that where the data is published, and I can see that hey, here my topic 2 is also working nicely, and the data is coming in. And then like of course the Grafana dashboard also has also data from the second one. So it's like quite handy tool like the Forge to actually harmonize the data and then publish it for both OPC UA clients, but also like subscribers that like via MQTT broker.
Nice, awesome. Yeah, I mean, so yeah, go on.
Feel free. Like then I was just thought that I could also like now if when I have this dashboard, so then like there is always, of course, possibility to have a dashboard that is directly connecting to the OPC, like the server, a little bit like the browser, except like now it seems my nice client dashboard doesn't start up, so I skip it.
I see.
Yeah. Okay, but hey, did you have a comment on this?
Well, comment just overall. So, anyone in the audience, if you've got any questions, please feel free to drop them in the chat, and then we'll address those ones here on the call. So, basically, to kind of like summarize this, how I understand it is basically you've got OPC UA data sources, and you've got OPC UA Forge, and then within Forge, you're able to connect to those OPC UA server data sources and then create a model or import a model. You can create it using any tool, import it into OPC UA Forge, and then create an instance of that model, and then use your data sources to map data into those properties of those instances that you've created. And then from there, that information model gets exposed to OPC UA clients that need to consume that harmonized information model, or that could be published using OPC UA over MQTT. So
yeah, exactly. Yeah. And like you see, like these, like when I create these instances of these, like now in this case the wind turbine 1 and the wind turbine 2, so these, they look exactly the same, like here when you, like, of course here like on the Forge display, but also for the any client that is connecting. So kind of like code that you write once that works with this kind of instance, like it will work with all the, also like, yeah, with all the instances that exist on this OPC UA server, or what, like any other OPC servers that would have like this same model.
Oh, nice. Okay, so it seems like we've got a question from Ravil. So he's asking, what targets can Forge forward data to other than MQTT?
So at the moment, like the like, of course, like the Forge has an OPC UA server, so like you can connect it with an OPC UA server and actually like with any client. So that's of course one option. And actually here is the our monitor or dashboard made with our monitor application that is a very normal OPC UA client. So that's one way of doing it. Then like the basically like we if we support both, like this get a little bit technical, but like UADB and JSON encoding with the PubSub, and then of course like the basically the UDP and MQTT, but I don't really see like what would be the use case for the UDP, honestly, with this application. Probably in future, like we will add like REST JSON interfaces in general, but like there, like it's a little bit like we need to think about whether we would like to use still the OPC UA REST JSON, or should we create something a little bit like own proprietary way. But at the moment, we try to stick that everything here is standardized OPC UA. When we implement the REST JSON, there we need to really think about it a bit, whether, yeah, how we do it. But hey, I hope this answered your question.
Yeah, I'm sure it does. So actually, Ravil has a follow-up question, which I think you may have already answered. So he says, can the data model from Forge be accessed over OPC UA server interface from OPC UA clients?
You mean like like, for example, this wind turbine data model? So let's see, like, if I understood correctly. So like now I have connected to this Forge OPC UA server with this browser, and basically like if I would know where to find, but like here, of course, under the types, like there should be all the types that exist on the server. So of course this wind turbine type is only one type among all the others. But to be honest, like now you asked a question that I have never never thought before, like, so I cannot probably find this to you right now.
Yeah, so I think it's been answered, because basically his question is, you can connect from UA Expert to Forge.
Yeah. So there it is most likely somewhere, like all the types. So but in basically, like, yeah, okay, here is the windmill type, as you see. So like every OPC UA servers, they kind of like, for the clients, they provide the information of all types that exist on the server. Yes.
Okay. All right. So I think that's I think that's an answer. Okay. So if anyone else has got a question, please feel free to drop it in the comments. So maybe while we still wait for a few other questions, if there are any more questions, I think we still have got a few more minutes to go. So you actually demonstrated the ability to scale a value. Do you already have some data transformation capability, or are you planning to add it in the future, if not already?
Yeah. So at the moment, like the what we can do, like, for the values is that we can set an offset, we can scale. Then we can also, like, if it's an array, like if on the server it's an array variable, so we can tell that we only like want to have the, let's say, index number 1 of the array to the node, or we can like if it's like a set of bits, so we can read a certain bit just. But that's the capabilities that we have right now. Of course, like, we have some ideas of some little bit more advanced data modifications, but those, let's say, doesn't exist now. If we really have like more time, I can of course show one more thing. So what's the event based communication that I little bit told as well. So here in the event generator, it is possible to create or first like create templates of certain type of like events. So like that then can be used like to when you map them kind of to the actual nodes and actual servers. And here, for example, I have made an event that basically like says high wind speed, and then it will take the wind speed, the actual wind speed variable there, and then it would say speed is speed over 10, and then I have made a actual event generator here, so with that triggers if the wind speed is more than 10, and then it will like, well, here it basically just says that read the wind speed to the wind speed variable on this message. And how it then works here is that if I take the event view, so actually I can go to the if I clear the table. So as you see, like now it's sending this kind of high wind speed warning because the wind speed is pretty much all the time over 10. And this feature can be used, for example, if you have a production batch that gets ready and you would like to send, like, let's say, production report. So there is a bit going up, the batch is ready, you read like variables that state how much was produced and how much was different things consumed and so on. Gather them in one message and then send to MES, for example. Or actually, this can be also then sent to the cloud.
Okay, perfect. Yeah, I think we actually had one more question here, but it looks like Lucas might have answered that one. So maybe for the benefit of everyone else here, Ravel is asking about how data flows into InfluxDB. Is Forge pushing data to it directly?
Yeah, so like now I didn't demonstrate, of course, this at all. So the data, like when you are using this like historical access feature, which I have now in the last slide, actually also there is other feature that I didn't demonstrate, so then like the Forge is yes, like writing this kind of like a, well, InfluxDB understandable like file out of the changes that are to the nodes that it's subscribed. And then like for this historical access, we use kind of a little bit like our proprietary format to store the data, so that like we can then also read the data. So there is nothing that can be customized on this historical access feature. But yes, it's storing like it doesn't use any OPC UA plugin that comes with the InfluxDB, if that was the actual question. You can of course use those as well, and then you can customize a little bit more like how you store the data to the InfluxDB.
Okay,
perfect. But yeah, and actually like here is the all the features that we have in our 1.0. So one that I didn't either like demonstrate is this data exchange. So that is just that like you can define that if certain value change on certain OPC UA server, then you can copy the value to another node on another server.
Okay.
So that's like sometimes handy if you have a like a production process having like several machines in a line, but you need to kind of like build some kind of like a data exchange between the two machines, and there is like currently nothing for that.
Oh, I see. Nice. I see there's one interesting feature that I see, the information modeling. Does it mean that you'll be able to build your information model within the OPC UA Forge platform?
No, with the information modeling, we basically mean that like the tool that I showed, that you can build the information model of your server, like with the web interface. So you can add like nodes in hierarchies. You can add like how many levels you like, and then like create such node types that you like. But we don't support, we kind of support in information like modeling, like creation of instances to the address space, but we don't support yet like creation of like these kind of like models or object types.
Okay, I see. Perfect.
So
Okay.
for that, like there is a few tools at least available. At least one is open source even, but we use like for the type, like creating the information models types, like we use this UA modeler, which we are distributing, but it's unified automation product.
Okay, perfect. So, for those who want to try out this product, what are the next steps?
Yeah, so the next step is, of course, like feel free to go to our website and there go to the Forge page, and then there is a button that says contact us or something like that, and fill in your contact details, and we will get back to you with a Forge installation and evaluation license. We might be asking you like a few questions before that. Or either you can, of course, just send an email to the sales@prosysopc.com.
Okay, perfect. So thank you so much to our audience. Thank you for taking the time to come through and to join us on the session. And thank you, Pyry, for taking the time to put together such a wonderful presentation for our audience. It was really informative. So thank you so much. And I think if there are I think, I don't know if we've got one more time for one more question. So I think Ravil is asking about, is there a container available at Docker Hub?
No, but if you like to have like the Docker container, just let us know. Like basically, like we will provide you download link or a link to a page where you can download the different versions. Yeah.
Okay, perfect.
But so far, like we haven't, like, I mean, this is anyway kind of like a special product, so we feel that like we would like to have kind of like a control who is using this.
Okay, perfect. So I think with that, we come to the end of the show. So thank you again for taking the time.
Okay. Yeah, and hey, thank you, Good Shai, for giving us on our me the opportunity, and I really appreciate it, and it was fun, and I hope like the audience were able to understand at least half of the things that I explained.
Oh yeah, absolutely. Thank you.
Okay, thank you. Bye-bye.